Hi, let's move on to partial fractions types 2, where the rational polynomial function has repeated linear factors in the denominator. Alright, types 2. For example, you have any fraction that look at this form. You have x power of 2 and x minus 1. Alright, this will be a repeated linear factors here. What's the repeated linear factors? Because you see that x squared can be rewrite as x multiply x, right? Or we can say that x minus 0 multiply x minus 0, right? It's a linear factors also, a repeated linear factors, a plus b to the power of n, which this is a linear, right? It's a linear with a power more than 1. It must be 2, 3, 4 or 5. So if this case happen, so we're going to rewrite this in the form of is a type 2, so it will be a different form. So it will be a over x, start with x because x squared, and you have b over with x power of 2 and plus with c over x minus 1, right? You see it here, you have a over x, b plus with b over x squared, means if x squared you will write as x first then x power of 2. Okay, if you're not very understand, let's look at another example. X squared minus 1, and let's say here you have x minus 1, and you have x plus 2, for example. Okay, x plus 2, x plus 5 to the power of 2, right? To the power of 2. So, okay, I'll just write it as a power of 3 because this is something, a repeated linear factor. Why? Because in the form, you can see that there is a form where there is a ax plus b to the power of n, which the n is greater than 1 on the denominator, in the denominator. So, it must be a linear factors. So now, if for this, you have to rewrite this in the form of a over, for this you have only single, right? It's a linear factors. It's a linear factors, but this is a repeated linear factors. So you have to start with b over with, at first, x plus 5 to the power of 1, right? Power 1, followed by c, x plus 5 to the power of 2. 1 become 2, and later d become x plus 5 to the power of 3. Can you see that? 1, 2, 3. Alright? If this one is 4, so you will have another one, e over x plus 5 to the power of 4. It depends on how many times it's repeat. Okay, I will give you more example. For example, you have 5x squared plus 4x minus 1. So, and here you have 2x minus 1 and square, and x minus 2 to the power of 3, for example, right? Okay, I just give you some complicated cases, okay? For example, here you have x plus 1. Okay, this is just an example, right? So if you have, this is a repeated linear factors. Linear, but power of 2 is called repeated. So this one x minus 2, power of 3, so repeated also. This one is a linear factors. So how to rewrite this thing? Be careful. So you have to write as a over with, okay, for this I will write as x plus 1. I will deal with this one first, x plus 1, and followed by 2, right, power of 2. So you have b over with 2x minus 1 first, followed by c over 2x minus 1 to the power of 2. Then we stop here. For this one, done, okay? So power of 2, right? So 1 and 2. And now go for x minus 2 power of 3. So you will have d over with x minus 2 power 1 first, followed by e. Wow, this will be very complicated. X minus 2 to the power of 2, followed by f over with x minus power of 2 power of 3. This will be the partial fraction for this polynomial rational function. So I doesn't want to calculate for the ABC up to f for you. Alright, so this is complicated. This is just for me to tell you that if this is the case, this is your partial fraction. Alright, so it depends. If you have power of 2, you will have 1, 2. If you have power of 3, you have 1, 2, 3. Alright? So okay, this will be the type 2. So now I will in the same video I'm going to teach you how to find the value of A, B, C if this is the case of repeated linear factors. Hi. Alright, let's look at this partial fraction. Okay, so you look at this. At first, before you're doing partial fraction, you have to identify the types of partial fractions that for this polynomial rational functions. Alright, so you look at this one. This is degree 2, and you expand this, you have your degree 3. It's a proper fraction. Okay, so proper fraction doesn't matter. We can continue doing our partial fraction. So, but you see that the denominator, there is one repeated linear factors here. So which is x minus 1 to the power of 2. Without the power of 2 is okay, right? But with the power of 2 here, so you have to consider type 2. So which you can have write at a over with x plus 3. This is a linear factors. This is a repeated linear factors. So you're going to write this as a b over with x minus 1 first, right? Power 1 first. Followed by another one will be c over with x minus 1 to the power of 2. It must be in this form, alright? So this is a partial fraction for this rational function here. So how you going to find the value of a, b, and c? So there are two types of techniques I'm going to apply, which is substitution, and another one will be comparing the coefficient. In the previous type 1, I haven't teach you about comparing the coefficient. So okay, let's look at this. Okay, you can get the technique by looking how I do it. So at first, same thing, you have to combine the fraction. Okay, you have x plus 3, x minus 1 to the power of 2. Because, you see, you need this, right? You need this. So in order for x plus 3 to be the denominator to have x to be in this form, so you have to multiply. You have to multiply with x minus 1 square, right? Of course, if you multiply on the denominator, numerator also we have to multiply, right? So means the a, you will have x minus 1 square, right? Let's look at b. Let's look at b. As you know that this one, if you write, it will be have x plus 3, x minus 1, x minus 1, right? Because x minus 1 square is x minus 1 multiply x minus 1. So you look at this. You have already have one linear factors x minus 1. You have x minus 1. So in order to be square here, so you have already have x minus 1 here. So you need these two, right? So it means you have to multiply the b with x plus 3, x minus 1. Same thing here also, you have to multiply with x minus 1 and x plus 3. Why? Because after multiply, you will get square x plus 3, right? So then the b, here you have x plus 3 and x minus 1. Alright? So let's look at c. Let's look at you analyze one by one. So c, x minus 1 square. Square means you have these two, right? You already have x minus 1 square. So you need x plus 3. You need another factor is x plus 3. So x plus 3. So means that c, you will have x plus 3. So now you have already confirmed that this is correct. You have double check everything. So now you compare, you do comparison. Comparing the denominator is the same. So you're comparing the numerator, right? By comparing the numerator. So you will have x square equals to ax minus 1 to the power of 2, right? Plus with b x plus 3 x minus 1, right? You're comparing the numerator here, right? With this. So plus with c x plus 3, right? This is a very important. So you must make sure that this is correct. So this, I put it at asterisk. So I'm going to find the value of a, b, and c. So very easy. So you want to find A, all right? You want to find A. You're going to find A. So what's a suitable value for you to substitute? Right? Substitute x equals to the suitable value of x. I was using the word suitable value of x. So for example, you want to find A, right? You want to find A. You have to make this 2 become 0, right? I have make this 2 become 0, then you can find A easily. So you look at these two, B and C, you have a same factors here, right? You have x plus 3, and here you also have x plus 3 here. So the best here is you substitute x equals to minus 3, negative 3. Because negative 3 plus 3 is 0, right? 0. So into, substitute into this equation here. So you have negative 3 to the power of 2, slowly, negative 3 minus 1 square. Right? Of course, here will be 0. If you write also, it will be 0. So then you have negative 3 square, you have 9a. Negative 3 minus 1, you have negative 4. Then you have 16, right? Square. So a, you have confirmed that is 9 over 16. Right? Okay. You have done finding the a. Alright, let's move on to b. Right, you for sure you have find some problem here. If you pause the video and you try to think how to find b. By eliminate these two terms. You have to make these 2 become 0 to find b, right? But this case is different. Because why? If you look at this, x minus 1, you have it here. X plus 3, you have it here. Right? So if you put negative 3, definitely these 2 will become 0, right? Become 0. You cannot find b also, right? So if you put 1, let's say you choose x equals to 1. Let's say you choose x equals to 1. You put 1 here. 1 minus 1, 0. 1 minus 1, 0. B also 0. So you cannot do anything. So it's the best here is you find c first. Never mind, you can find, no need to follow the order A, B, C, right? Mathematics, right? So you find C. So you can using x equals to 1. Because x equals to 1 will make these 2 become 0. Then you can find the C first, right? You can find the C first. So then B later, we consider later. So you find C, x equals to 1 because 1 minus 1, 0, find C. Okay, that's fine. So you substitute this into this equation here. So you have 1 square equals to a. This one don't need because 1 minus 1, 0, right? 1 minus 1, 0. So the first 2 term is 0. So C, 1 plus 3. 1 plus 3. So you have 1 equals to 4C. So C is 1 over 4. Tang tang. Sudah cari C, sudah cari A. Already find A and C. So the problem here is how to find B. How to find B. This one will be different, right? For this case, it will be different. You find B, you cannot substitute. So if you have no choice, you finding the x here, you put 1 is you finding the C, not B. You put negative 3, you find the A but not the B. If you have no choice, any value, you can choosing any value of x. I was choosing 0. Then student will ask, sir, can I choose 1 or not? You already choosing 1 here, right? Sir, can I choose negative 1? I see. Negative 3, here 1. Is negative 1 already used? Not used yet, right? So we are not using 1 yet, so we can choose 1. We can choose negative 1. We can choose 100, any number that is not deep between two. It's not this and not this, any number we can choose. But of course, we will choose a number that easier for us to calculate. For example, I choose 0. Right, I choose 0. This is a special case here. So I put 0 into the equation. So I do this when I have no choice. Alright, I have no choice. So any value, I choose 0 here. So 0 square equals to A. 0 minus 1 square, right? Never mind, just substitute. Believe that you can get it. 0 plus 3. 0 minus 1 plus with C, 0 plus 3. Doesn't matter. 0, negative 1 square, you have positive A, B, plus with B. So you have 3 times with negative 1. So you have negative 3 plus with 3c, right? 3c, negative 3b. What's it on a? So you have a minus 3b plus 3c equals to 0. This is a relationship between a, b and c. So you can find b, right? Because you have already know the value of c and a, right? C and a. So you can just substitute 9 over 16 minus with 3 times with b. You want to find b, you don't have b, plus with 3 times with 1 over 4 equals to 0, right? So you substitute what you have here into here, then you're finding the b. So I know that it will be 3b. The 3b, if moving there, right, add 3b both sides. So you have 9 over 16 plus with 3 over 4. Alright, you have to calculate this. 9 over 16 plus with 3 over 4. You have 21 over with 16. Right? 21 over 16. So your b will be, you divide 3 both sides. 21 over 3, you have 7 over 16. Ta-da! Now you find your b. You have a, you have b, you have c. Wow, you have complete your work, right? So finally, you do conclusion. Conclusion. Wow, very messy, right, my work. So hope you can understand. So your a, therefore, your x squared over with x plus 3, x minus 1 square is equals to, first, what's your a? 9 over 16. So it will be 9 over 16 x plus 3. Right? 9 over x plus 3. Followed by b. What's your b? 7 over 16. Alright. 7 over 16. So 7 over 16 x minus 1. And lastly, your c. Your c will be 1 over 4 plus with 1 over 4. Remember, here is 1 over 4. I bring the 4 together with the denominator. It will be x minus 1 square. This will be the partial fraction for this polynomial rational functions. Hope you understand. I will give one more example for you. Hi, let's look at these examples. Okay, look at the denominator and look at the numerator. First, you have to know that this is a proper rational function. If this is a improper, improper means that the degree is power of 3 here, because if you expand have power of 3, the degree is the same or higher, it's called improper, right? Improper. So improper, we have different approach. We will discuss in type 4. So now it's power of 1, and here is you have power of 3, so it's proper, because the degree here, power of 1, degree here, power of 3, so it's less, right? So less. So then next we consider about the repeated linear factor. Is there any repeated linear factors? Okay, without the power of 2 here, this is linear factors, right? But with the power of 2 here, this is a repeated linear factors. That means the x power of 2 is a repeated linear factors here, which is x multiplied with x, right? Multiplied with 2x minus 1. This is a repeated, right? The same thing, repeated. So now, for this case happen, you have to decompose this into a over x. A over x, and another one will be b over x to the power of 2. If let's say this is x power of 3, if this is x power of 3, then you will have another one c over x power of 3. Understand? So then you have c over with 2x minus 1. This is not repeated, right? Not repeated, only this. So how to find the value of a, b, and c? So very simple. So first you must make sure this is correct, right? Correctly, your correct form of partial fraction. So now you have to recombine this by multiply. Remember this, you have x multiply 2x minus 1, right? So you have already one x, right? You have one of the x here. So you need these two, right? So means that your a you will need x and 2x minus 1, because the denominator you multiply x and 2x minus 1. So of course here also you have to multiply with x and 2x minus 1. So in your mind, so b, x squared. So you know below here you must have x squared 2x minus 1, right? So you look at the b. The b you have x squared. X squared means xx. So you need 2x minus 1 here, right? So the b also you have to multiply with 2x minus 1. This is how you think, right? So plus with c, right? Look at c. C you already have 2x minus 1. Sudah ada 2x tolak 1. So you perlu x dengan x. So you need x square, right? X and x mean x square. After that you have equate the denominator. Now you're comparing the numerator, right? By comparing. So by comparing, you know that 3x plus 1 is ax, 2x minus 1 plus with b, 2x minus 1 plus with c, x power 2. So this will be the main equation to find the value of a, b and c. So now same thing here. You want to find a, right? You want to find a, you want to find b, you want to find c, right? You have a, b and c. So if you want to find a, you look at the common factor here. There are no common factors here, right? Tiada faktor sepunya. So if you put x equals to 0, if you take x equals to 0, if you take x equals to 0, here you will become 0. Because x, here you have x. If you put x 0, these two will become 0. Then you're finding the b first, right? So if you choose 1 over 2, 1 over 2x minus 1, 2x minus 1, you choose 1 over 2. You know that 1 over 2, hello, you think 1 over 2. So you have 1 minus 1, 0, here also 0. So these two become 0, then you find c, right? You cannot find a by substitute 0 or 1 over 2, right? So then, tinggalkan dulu. Because you have no choice. So you can find b first. You find b first. So you find b, you substitute x with, if you find b, okay. Because if you find b, these two will become 0. Because you have x, here you have x squared. As long as you substitute x with 0, these two will become 0. Then you are getting your b, right? Finding your b. So you have 3 times with 0 plus 1. Substitute this into the equation. 0, so you put 0, a times 0, 0, x squared 0, so 0. So you have b 2 times with 0 minus 1. So you have 1 here, then you have b negative 1, b negative 1, you have negative b 1. So b will be equals to negative 1. Now you have found your b, right? And now leave with a first, find c first. So find c, you know that c, you only have x squared. But here you have 2x minus 1 and 2x minus 1, right? You know that 2x minus 1 equals to 0 when x is 1 over 2, right? When 1 over 2, this will become 0, right? Become 0, become 0. So you substitute x equals to 1 over 2. Very easy, right? You substitute x with 1 over 2. So substitute into the equation. You have 3, 1 over 2 plus 1, which is equates to, now this of course 1 over 2 here will be 0, right? 0, 0. So tinggal sini aja c 1 over 2 square. Then you can find the c. So 3 over 2 plus 1. You have 2 over 2 here, right? 2 over 2. So you have 3 plus, so you have 5 over 2, which is equals to c 1 over 4, right? 1 over 4. So c will be 4, right? 1 over 4. 4 multiplied with 5 over 2. 2, 2, 4. So c we will have 10. Now you have c equals to 10. Good, right? You have b, you have c. Now you want to find a. Find a. The problem just now is what? You putting 0, not okay. You're getting 0. You're putting 1 over 2, getting 0. So no choice. So if this happen, don't choose 0. Don't choose 1 over 2. Choose another number. Don't use 0. Choose a number that's easier for you. I will prefer you to choosing 1. Sir, can I choose negative 1? Okay. Can I choose 100? Okay. Can I choose 1000? Okay. Anything is okay, but not 0, not 1 over 2. Alright? It's already chosen. So x equals to 1. X equals to 1, so you substitute 1. 3 times 1 plus 1. Right? So choose 1. If you choose 1, then okay, here will become not will become 0, minus 1. Plus with B, you choose 1. 2 times 1 minus 1 plus C, 1 square. Isn't it? Very easy. Don't go and choose 100. It's okay, but wasting your time, right? So 3 plus 1, you have 4. 4. So this one is 2 minus 1. You have 1. 1. You have A, right? 2 minus 1. 1. So you have B. And C also 1. A plus B plus C is 4. Aha. So now you know that 4. What is your A? Don't know, right? A you want to find. B, negative 1. C, you can get from there 10, right? So then you have 4 equals to A minus 1, right? Minus 1 plus 10, you will have positive 9, right? So therefore A will be 4 minus 9. You have negative 5. Now you know that A will be negative 5. Done. You have find A, B, and C. Then you have to be slow and steady, right? While you're doing this partial fraction. So, okay, then at last you have to do a conclusion, right? You have to do a conclusion for this fraction here. Okay, I can just write here, okay? Okay, you have to rewrite this thing. Therefore, your conclusion will be, what's your A? Right, what's your A? Your A will be negative 5, right? Negative 5, so here will be, you have replaced by negative 5. What's your B? Negative 1. So, positive, negative will become negative 1 over x squared. Plus with C, C is 10. Just replace with 10, and this will be your partial fraction for this polynomial rational function with repeated linear factors. Alright, that's all. Okay, for the next video we'll go to type 3.